We do have an ellipse, so we have to work from it. Well, we want to write out everything about an ellipse, including graphs and finding all the different points where the focus and everything like that is at. What we do is going to be basically the same thing. We're going to try to get it into the form, with that vertex form, where it was x minus h quantity squared plus y minus k quantity squared over a and b equals 1. But where you had the a squared, b squared part, and that was what told you how it was being stretched. If a squared was larger underneath the x squared, which direction was it being stretched? Stretched left and right, and if it was under the y squared, it's stretched vertically. That's the difference between the a's and b's. So what we do here is we're going to try and set up a completing the square problem. I want to group the x's together, the y's together, and send the constant to the right. And why do I put those blanks in again? To remind you. But now what do I have to do about the x squared here? That's what I'm doing. I was doing this first. Whenever you complete the square, your really only rule of doing so is that your first term coefficient has to be 1. If it's not going to work. So you factor out the 4. You got to put it back then. Since I took one out, I got to put one back. A lot of times you guys will probably skip right to that step right away. There's no reason to have to write it out twice usually. Now I just go through it. What's half of negative 2?
Half of negative 2 is
Negative 1, good. So the negative 1 goes here. I square it, and I put it here and here. What's half of 4?
half of 4 is 2.
I square it,
It's 4.
I put it here and here.
Whoa.
Crazy stuff, isn't it?
And you divide by 16.
Then I divide everything by 16. And we get, I know I have it stuck in my head now. So happy. And now you are at the standard form. Which means all you have to do is, well, everything now. Where's your center?
-1, -2.
Which way is it being stretched?
Towards the up and
To the up and down. Very good. So put a little spot like that. That way you know you're going up and down. You're vertically stretched or vertically challenged if you're short.
But
I know. Just,
I know.
whoop, just the. There's my center. What's a squared?
4. So 2.
What's a squared? 16.
Oh.
Remember the a squared for ellipses, a squared is always the larger of the two.
Oh.
How do you find c squared?
B squared. So 12.
It's a squared minus b squared. So now we start plotting. It's really fast at this point then. So a is plus or minus 4, b is plus or minus 2, c is going to be plus or minus 2 root 3 because it's 12. Hey, buddy! Hey, have you watched The Walk of Life?
We should show them one.
Yeah, show 'em one.
All right, you can see this because you'll appreciate it. Anyway, so we know we're stretched vertically, so we just have to walk. Do the walk of vertices.
Is there words to that song?
Yeah.
Oh.
Alright, we listen.
Here comes Johnny. And what I say, hey, baby, I got something.
Thanks.
Oh yeah, the boy can play. Dedication, devotion, spend it on hanging. Whatever. Anyway, so count 1, 2, 3, 4. This is why I don't sing for a
What happened to
living.
your song?
Oh yeah. 1 little 2 little 3 little spots. 4. So we have vertices at. Let me just make a list. It's the easiest way to do it. Just make a list off the side so we can go right through all of them. We're at 1, 2, and 1. 1, little 2 little 3. Let's see, 2, 3, 4, 5, 6. And notice your center is the midpoint of your vertices. It's the walk of life.
Wow.
You guys need to stop this.
It's awful. The co-vertices. The book calls these major and minor axes. Major axis is the vertex. Minor axis is the co-vertex. Oh, this was something negative too. Oh, nope.
No.
Stop. Yeah, center is negative 2. And then let me draw our awesome oval.
I started to
Hey. Last thing I do is we got to put in my foci. My foci is the distance C. C is the distance from center to the focus. It was the square root of 12. The square root of 12 is more than 3, but it's less than
4.
So it's about here-ish and here-ish. We just write it out. One that'll be negative 2 plus root 3. I'm sorry, plus 2 root 3. And 1. And that's how you write those out. Don't get decimals, just write them out in radical form. It's much, 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 much easier. How's your math working out? Not playing. Oh, you're doing it? Why'd you do this now?
What? I'm having yesterday's work, so I can understand this work.
Just walk away.
This work is done.
It's a joke. I'm joking.
Look at what you did.
Hey, you? Oh. It's like you start like doing like a pep talk.
At the end of the year.
I told him to do it right when you said like,
Sometimes
alright, this is the
it's
final.
so heavy.
Yeah, when you put the homework up on the board, just
Just like playing that
You
on
should,
the
you should play that like all for the final.
The bell rings.
Wait, what's this? We have 5 minutes left on the final and you just start chatting.
Well, then I gotta play the final countdown.
or Jeopardy.
My kids love that song. It's the final countdown. They don't know anything else. They just yell it. So write the equation given this information. You have foci at plus or minus 5 and 0, and then major axis length of 12. Remember, the major axis is the axis of from vertex to vertex. So it's going to tell you whether it's from here you'll be able to tell if it's stretched vertically or horizontally because you know where the focus is. First thing you always do with these problems is, again, plot what you know. If those are my foci, what direction does this have to be squished? Horizontally, very good. This has to be a horizontally stretched. If they were vertical, the foci would be above one another. If they're horizontal, they'll be across one another. Because they're going to be where the vertex looks at. Now, what happens at the midpoint of the focus?
The center.
Where's the center?
0.
Center is at 0, 0. So right off the bat, I know that we are stretched left and right, which means it's going to be an x squared over a squared and a y squared over b squared. Why did I not put in an h and a k?
Because it's not
It's not shifted, good. It told me also that I had a major axis length of 12, which means the overall distance between the vertices is 12. If you're at the center, that means it has to go one way and the other way. So your endpoints are at 6 and 6.
Oh my God.
So that means your A value is 6, which means your A squared value is. And I know that our C value is 5, which means our C squared value is 25. Which means C squared is A squared minus B squared. So 25 is 36 minus what?
B squared.
Is it 9? Or is it 11?
It's 11. That's sure.
I do that all the time too. So now you can write it out. X squared over 36 plus y squared over 11 is 1. That's how these work. Okay. The last little bit I wanted to show you is what's called the eccentricity. And that's a value within all ellipses that allows you to tell whether how things are squished or more circular in nature. The reason they came up with this or figured this out is because of planetary orbits. Planetary orbits aren't all circular. They're oval-ish, ellipses, elliptical-ish. But elliptical is a circle, right? But it makes an oval motion. Weird. Anyway, so what happens here is that you're able to decipher the astronomers figured out that the different paths, not obviously not all the planets revolve around the sun on the same path. Did you know that?
No.
Well, now you do. So what they're able to calculate is by the shape of the path, how much stretch there is in something. And that's called the eccentricity. And this value E, they call it, it's not the E button on your calculator. This eccentricity, the E of an ellipse is given by the ratio C over A. That's what it is. And it just, all that tells you is how scrunched or how narrow an ellipse is. Now, the one thing is that they can say this. You have an eccentricity of, let's make this work. And you might know your center. Doesn't this give you an A and a C value to help find distances?
Yeah.
That's the other thing about this. So you may be given a fraction, and just knowing what the parts are, it's the C part and the A part, so it's C over A. It allows you to do all the rest of the equation stuff. That's why we talk about it here. I know you guys never saw that last year, so we might as well add a little new things to all these, where there was that the tangent line stuff from the other day, or this, just little parts. So let me show you how a problem like this is going to work.
I know.
Find the equation of an ellipse who has vertices at 0, comma, plus minus 8, and an eccentricity value of 1/2.
Hey, doesn't that?
What's that?
I said, hey, doesn't that look familiar?
It probably does.
The E equals 1.
Because I wanted to make sure I get a C value that wasn't like negative, and it just, I knew it 1/2 worked because I remember seeing that problem before. So it doesn't tell us direction or anything yet. We don't know where it's going until we start plotting things. Remember, it's always easy to plot to figure out what direction things are going in ellipses, and then next week when we talk about hyperbolas, it's going to be very, very easy to tell which equation you're working with. So let's see, we have plus minus 8. 0 plus minus 8. Hey, if those are my vertices, what direction is this going?
I think it's going.
I think it's going vertical. Okay, it's going vertical. This is so it's going to be x minus h quantity squared over B squared. What's your H and K?
Zero, zero.
It's at 0, 0 again because last time I checked, 8 and 8 are equidistant, or 8, negative 8, excuse me, are equidistant from that same point. That point is 0.
No. I like
So when you guys are walking across the stage getting your diplomas and stuff like that, just have that going through your mind.
I walk out of this class.
Turkey. You just bring a boom box.
Stand there with it on my hand,
Yeah.
just like this. Wear a trench coat.
Yeah.
It's from the
We
movie.
get it. Madeline watch movies.
How far apart? What's your A value?
A is 2.
Because it's C over A. Excuse me. So let's see here. We can get the rest of our info then. If that's C over A, so then A is 2, so A squared plus or minus 4. Wait a second, that's not giving us the 8. Did I copy the wrong problem?
Yeah.
No, I didn't.
How
Did I? Well, I might have cut off the 2. I don't need here, insert a theme music. Oh no, it's not working. Duh. Hold on. So it's going to allow you to figure this out in a second. So couldn't this also be a simplified fraction? Rather than that? So it could be. So right now we know that our A value has to be 8 according to the equation that we're getting.
Yeah.
Because that's your distance from center to here. That has to be 8. What's C have to be then?
Oh, 4.
Has to be 4.
Well, that's silly.
That's a
I forgot that you can simplify fractions. Silly me.
That's some
Okay, well,
That's like worse
not
than
okay.
that.
I'm gonna
Sorry.
mess it up.
So if C squared is 16, A squared is 64, what is B squared? 48. So B there.
Word.
I thought it was good.
yes.
That's about as worse it gets. It'll make you have to simplify a fraction. I know. Very sorry. Do those other examples help from what you were looking at yesterday? I know that I gave you guys like 6 or 7 yesterday, right? I'm so sorry. We did. Can I go to? Let me get this one that had all the problems.
You guys, I don't know how it's going to start.
That's where we were at yesterday. So we went up 30, and then 39. One of those. 40 to that. That's on 750. Starts on 750.
Yeah, I do.
Yeah, I'm tired of getting gas. It's all like a pain day sitting in a chair. What?
Yeah, do those. We'll add those three to it. All right, then we'll see if there's questions on any of this junk on Monday. And then we'll talk about hyperbolas,
Okay.
but not hyperbole.
You mean hyperbola?
Ebola? I don't
That's
know.
what Pliscoda was.
That's what everyone thought it was.
You'd be like parabola.
Hyperbola?
Parabolas, and you could read it to me about what they were, and how like
Oh.
No, the whole class.
No, like our teacher said.
Your mom's nice. I like your mom. She's a mom.
So think of like this.
Jack was in our class.
You were?
For like, I think it's
That had to be awkward.
Yeah, so it's.
Really?